Can the X-44 Manta truly destroy the formidable sixth-generation stealth fighter? Recently, the United States embarked on quite an expensive investment to build the next generation of fighter jets that would dominate the skies. This new fighter is said to feature the most advanced technologies that the world has ever seen, and in terms of lethality, it is expected to be designed with more lethal capabilities than the Raptor. However, a new 300 million aircraft, the formidable Manta, is believed to have what it takes to destroy these new advanced fighter jets. What are the capabilities of this new $300 million aircraft? Does it have what it takes to defeat the NGAD in a dogfight? Join us as we explore the advanced capabilities of the million-dollar X-44 Manta that can destroy the sixth-generation stealth aircraft. It is no longer news that the United States is invested in the creation of a technologically advanced sixth-generation fighter that is said to replace the legendary F-22 Raptor by the 2030s. The Raptor is a technological marvel on its own, and despite it being the most feared air fighter ever developed, it recently got a massive upgrade that makes it even more formidable. Recent photos on the internet have shown a Lockheed Martin F-24 Raptor featuring new stealthy external fuel tanks and underwing infrared search and track sensor pods. Captured near the Mojave Air and Spaceport by Task Force 20, these modifications signal significant upgrades to the iconic aircraft. The new low-drag tank and pylon are designed to be more aerodynamic and stealthier than current tanks, allowing for supersonic flight with extended range. The pylons include smart rack pneumatic technology for improved ejection performance, crucial for maintaining air superiority. Though initially thought to be cut due to budget issues, the presence of the IRST system in the latest images indicates ongoing development. This addition is part of a broader $9 billion upgrade plan for the F-22 fleet, enhancing stealth, sensors, and overall capabilities. These enhancements are aimed at countering threats like China's J-20 fighter. Additionally, the F-22 serves as a technology testbed for the Next Generation Air Dominance or NGAD program, supporting the development of future air superiority systems expected to debut in the 2030s. With these upgrades, the Raptor remains a formidable opponent, capable of addressing near-peer adversaries well into the future. Now let's talk briefly about the features of the NGAD. Since 2015, the U.S. Congress allocated over $4.2 billion to the NGAD program. The program focuses on developing technologies for air superiority, potentially leading to a combination of manned and unmanned systems. Key developments include advancements in propulsion, uncrewed systems, materials, and sensors. The budget for FY 2023 was $1.6 billion, with a projected $11.7 billion through FY 2027. The program also aims to revamp the acquisition process, allowing more companies to participate. Production is expected to start around 2030, with similar programs underway in other countries. NGAD will advance stealth capabilities beyond fifth-generation aircraft, enhancing low observability across various wavelengths to counter future threats. The twin-engine design will offer greater thrust, fuel efficiency, and reduced heat emissions. NGAD will emphasize lightweight composites, allowing for more payload capacity and increased endurance for extended operations in vast regions like the Western Pacific. Its arsenal will include both kinetic and non-kinetic weapons, leveraging electronic warfare for rapid, lethal responses. The electronic warfare suite will ensure comprehensive situational awareness, integrated with other systems through agile electronics and sensor fusion. Off-board support will enable secure networking with other aircraft in control of drones, enhancing lethality and survivability. The aircraft's open architecture will allow for continuous adaptation to new technologies without dependency on specific suppliers. Digital engineering will streamline development, production, and maintenance, reducing costs and improving lifecycle support. NGAD's design features will surpass existing capabilities, ensuring the U.S. Air Force maintains air superiority over potential adversaries. With these features, it is quite hard to believe that any other fighter can successfully surpass the exceptional capabilities of the next generation of air dominance. Not even the X-44 Manta. However, to be certain, let's check out the characteristics of this new aircraft and compare it to that of the NGAD. The X-44 Manta was envisioned as a superior stealth fighter, surpassing even the Raptor, and this goal is quite similar with that of the NGAD program, which, as mentioned earlier in the video, is to replace the F-22 Raptor. However, unlike the NGAD program, which started in 2015, the concept of the X-44 Manta originated in 1999, making its design as dated as the F-35. The Manta, which stands for Multi-Axis No-Tail Aircraft, was an experimental aircraft concept studied by NASA in the U.S. Air Force. Its goal was to test if it could fully control yaw, pitch, and roll without traditional tailplanes, that is, horizontal or vertical. Instead, it used 3D thrust vectoring for attitude control. Based on the F-22 Raptor, it had a stretched delta wing design, but no tail surfaces. Back in 1999, Lockheed Martin unveiled the Manta, a bold vision for the future of aerial combat, which features a delta-shaped stealth fighter that broke from tradition by eliminating the conventional tail section. Unlike typical aircraft, which rely on vertical and horizontal control surfaces, the Manta employed thrust vector control. This innovative approach directed the engine's thrust to achieve exceptional maneuverability, crucial for high-stakes dogfights. Fast forward over 2 decades, and this concept has become a staple in the design of the U.S. Air Force's cutting-edge next-generation air dominance program. The latest renderings of NGAD's air superiority fighters consistently showcase this tailless, thrust vectoring design, reflecting Lockheed Martin's early design. After noting this similarity, people began to wonder if the innovations from the X-44 Manta might have influenced the designs of America's latest air-generation fighter. Just last year, the U.S. Air Force made headlines worldwide with the revelation that they had already designed, built, and tested a prototype aircraft from the next-generation air dominance program. This new jet, which is believed to be the most advanced fighter ever conceived, is engineered not just to compete with, but to decisively outperform the sophisticated 5th-generation fighters emerging from adversaries like Russia and China. Its design promises to ensure American air superiority for decades, embodying the advanced concepts that began with the groundbreaking Manta. Around the same time, the Air Force revealed an intriguing image celebrating its anniversary. This image showed a wedge-shaped aircraft with no conventional tail section, sparking curiosity about its connection to the NGAD announcement. Since then, official images from the Air Force and renderings from major aviation companies like Lockheed Martin have consistently shown similar wedge-shaped designs. Some have suggested that Northrop's impressive but ultimately sidelined YF-23 Black Widow II set the stage for this tailless design. The Black Widow is an American marvel of aviation engineering, a single-seat, twin-engine, supersonic stealth fighter designed to showcase cutting-edge technology for the U.S. Air Force. This sleek and futuristic aircraft was a fierce competitor in the USAF's Advanced Tactical Fighter competition, going head-to-head with the YF-22 for the coveted full-scale development and production contract. Though only 2 YF-23 prototypes were ever built, their innovative design and performance left a lasting impact on stealth fighter technology. It featured advanced aerodynamics, a high cockpit, tricycle landing gear, and a large weapons bay. Powered by 2 turbofan engines, it could supercruise at over Mach 1.6 without afterburners. The aircraft used fly-by-wire controls and a central management computer. Despite its innovative design, it incorporated off-the-shelf components from other aircraft to keep costs down. The aircraft was praised for its high angle of attack performance and stealth capabilities. However, Northrop is not the only aviation company experienced in building stealth fighters without tails. In fact, looking at these artistic renderings and considering the practical challenges of quickly developing a new fighter, the X-44 Manta might be an early version of what could become America's next top fighter jet. The name X-45 says it all. For years, fighter jets have typically included standard features like conventional tail sections with vertical and horizontal control surfaces. Both the F-22 and F-35 tweaked these designs a bit, but they still followed the basic blueprint. The Manta, however, took a bold step away from tradition. It aimed to achieve top-notch maneuverability without any of those tail surfaces, relying instead on innovative design and technology to get the job done. By eliminating the tail section, the aircraft's radar signature would be significantly reduced, resulting in an even stealthier fighter than the formidable Raptor. Recognizing the potential, Lockheed Martin teamed up with NASA to explore how to turn this visionary concept into reality. Creating an acrobatic fighter without a tail required a revolutionary approach, using thrust vector controls to precisely direct the aircraft's flight path. This innovation promised not only enhanced stealth, but also unprecedented maneuverability in combat. NASA had already seen great success with their thrust vector controls on the F-15 Active, a modified F-15 Eagle equipped with front-wing canards from an F/A-18 Hornet and thrust vectoring nozzles. This setup produced a fighter that could outperform the legendary Eagle in almost every way. Simply put, thrust vector control allows pilots to aim the jet engine's nozzle. In jets like the F-22 Raptor, the nozzle moves up or down, while in others, like Russia's Su-35, it can move 360 degrees, offering dramatic options for rapid direction changes during dogfights. The Raptor's thrust vector can allow the pilot to point the nose and weapons of the fighter down at an enemy jet as it passes by, and at the same time continuing to fly in the same original direction. In a close-up scrap between two fighters who are trying to successfully turn tighter than the other to get weapons lock, that same thrust vectoring capability allows jets like the F-22 and Su-35 to change directions far more aggressively than any advanced jet without the thrust vector controls can. While the F-22 leverages thrust vector control alongside its more conventional tail section, Lockheed Martin proposed using the Raptor's design as a starting point for this new technology demonstrator that could prove just as capable as the fighter designs we've come to see as convention in recent decades. Because the concept wasn't being pursued as a clean-sheet fighter development program, but rather as a technology demonstrator effort, starting from scratch on an aircraft design didn't seem practical. Instead, Lockheed Martin volunteered the Raptor. Although it isn't the newest stealth fighter from Lockheed Martin Skunk Works, the F-35 Joint Strike Fighter began its test flights 3 years earlier. The F-22 Raptor remains America's premier air dominance aircraft. Its superior capabilities in engaging enemy jets, coupled with its advanced thrust vector control, make it an ideal candidate for experimental advancements in this technology. At the time, the Pentagon was exploring various F-22-based concepts beyond its original role. As the world's first operational stealth fighter and a trailblazer in the fifth-generation jet era, the Raptor's unmatched air superiority and versatility made it a natural choice for developing specialized and innovative roles in the U.S. Air Force. While the X-44 concept was aimed to enhance the Raptor's stealth by removing its tail, another intriguing project, the Sea Raptor, envisioned deploying F-22 aboard America's supercarriers. This upgrade would have enabled the Raptors to fly faster, farther, and carry more ordnance than the F-35C currently slated for carrier duty. The F-22 Raptor had already redefined the fighter landscape with its integration of stealth into its very framework, setting it apart from previous air superiority fighters like the F-15. Unlike its predecessors, which relied on sheer performance and added radar-absorbing materials as an afterthought, the F-22 was engineered from the ground up to evade detection. With its formidable Pratt & Whitney F-119 engines propelling it to speeds of Mach 2.25, and its advanced thrust vector controls allowing it to deftly evade incoming missiles, the F-22 was a quantum leap in both speed and agility, embodying a new era in air combat technology. Today, the F-22 remains the most highly capable air superiority fighter on the planet, and in 1999, its lead over the competition was even more pronounced. But even the formidable Raptor could be even better if it could be even stealthier, and that's where a tailless Delta design could have produced real results. If the X-44 Manta could have offered similar performance to the F-22 while also being even harder to detect, it may have been enough to push this aircraft concept off of Lockheed's notebook pages and into their production facilities. However, the X-44 Manta wasn't just about superior stealth. It was designed to deliver a lot more firepower. Its sleek, tailless wedge shape not only enhanced its radar-evading capabilities, but also offered significant advantages in payload and range over existing stealth fighters. While the F-22 Raptor can carry a maximum of 6 air-to-air missiles internally, and the F-35 Joint Strike Fighter can manage only 4, the X-44 broad, unconventional fuselage promised a substantial increase in ordnance capacity. This design would likely have allowed for a much larger internal payload and improved overall lift and fuel efficiency, transforming it into a formidable powerhouse with a heightened strike capability. Originally conceived as the F-16 Scamp and later evolving into the F-16 XL, this aircraft took on Boeing's F-15E Strike Eagle in the enhanced tactical fighter competition. The F-16 XL's broad wedge-shaped fuselage granted it remarkable advantages over the standard F-16 Fighting Falcon, including enhanced lift, extended range, greater fuel capacity, and a much larger payload. While stealth wasn't a priority for the F-16 XL, its innovative design allowed it to mount weapons on external hardpoints with unprecedented versatility. Thanks to its expansive wing surface, the aircraft boasted hardpoints for a staggering 27 weapons, a significant leap from the F-16 Standard 9, making it a true juggernaut of firepower. Last year, the United States Air Force stunned the aviation world with the revelation that they had not only designed and built, but also tested a prototype aircraft as part of their next-generation air dominance program. While details remain unclear about how the X-44 Manta might have outperformed the F-22 in terms of payload and range, it's clear that its broader lifting body would have significantly enhanced its capabilities. The increased internal payload space and superior lift from the wedge-shaped design would have allowed the X-44 to carry more weight and operate more efficiently, optimizing fuel usage and extending its operational range. Despite the intrigue, definitive answers about the X-44's specific advantages remain elusive, leaving many questions about NGAD unanswered. As the United States Air Force approaches the unveiling of the Raptor's successor, the X-44 Manta's legacy continues to spark curiosity and critical discussion. The intent behind the X-44 was to push stealth technology beyond the F-22 Raptor's capabilities, mirroring the NGAD program's ambition to develop a superior stealth fighter. Reviving the X-44 based on the now-defunct F-22 would be as costly as starting from scratch with a new design. However, the essence of the Manta might still influence the Air Force's next-generation fighter. Renderings of the NGAD show a striking resemblance to the X-44's wedge-shaped tailless design, hinting at a possible lineage. While many have drawn parallels between this concept and Northrop's YF-23, the Manta's design images align even more closely with the proposed NGAD features. If Northrop's YF-23 is in the running, it's logical to think that advanced iterations of Lockheed's F-22 might also play a role in shaping the future of air superiority. Before wrapping up this video, let's explore the unique of this sixth-generation fighter, the F/A-XX. In July 2009, Boeing made waves with the public unveiling of its sixth-generation fighter concept under the F/A-XX program. The initial renderings showcased a stealthy, twin-engine, tailless jet with a tandem two-seat cockpit and a blended wing fuselage. Designed for versatility, the F/A-XX could operate either manned or unmanned depending on the mission. This concept falls into the 40,000 pounds weight class. Notably, the Northrop Grumman X-47B, which had been selected for the UCAS-D program, was also proposed as a candidate for the F/A-XX. By April 2013, Boeing introduced an updated version of the F/A-XX concept. This iteration continued the tailless twin-engine design, emphasizing stealth with its all-aspect capabilities. The updated design featured canards, which typically impact frontal radar cross-section, but their inclusion underscored a commitment to superior maneuverability and stealth. The fighter also incorporated diverterless supersonic inlets, similar to those on the F-35. The manned version of the F/A-XX appeared to have limited rearward visibility, relying on advanced sensors to compensate for this design trade-off. In 2011, the Department of Defense outlined a plan to phase out older F/A-18CD Hornets with a new fleet of 220 F-35s. However, a Navy analysis of alternatives in March of that year suggested three possible paths: buying additional F-35Cs, developing a new aircraft platform, or a combination of both for its next-generation air dominance program. By May 2011, the DoD was exploring the possibility of acquiring more F-35 to eventually replace 556 Super Hornets. On September 9, 2014, the Navy revealed plans to start an analysis of alternatives for the F/AXX aircraft in 2015. This effort aimed to explore the development of a new aircraft, a family of systems approach, and advancements in mission systems, avionics, and next-generation weapons. By April 4, 2019, Radam Scott D. Kahn, Director of Air Warfare, announced that the AOA for the F/AXX would be completed by spring, with a final report expected by summer. Once the AOA wrapped up in June, the Navy shifted into the concept development phase. Despite this progress, budgetary concerns emerged, with Brian Clark of the Hudson Institute forecasting that the F/AXX might end up as an enhanced version of the F-35 or F/A-18 Super Hornet. Until fiscal year 2024, much of the F/AXX was kept a secret under a classified special access program known as Link Plumeria, one of the DoD's largest R&D initiatives. Facing budget constraints, the Navy proposed delaying the F/AXX program in its FY 2025 budget request to prioritize immediate investments. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.